Hello everyone, George here, and in this video we're going to take our custom view a little bit further. In the last video we left off where we created a border class where we just drew a static element all around the area. We're now going to add time to our application, which is going to allow us to use things such as speed to update our views, or I should say canvas objects on the screen. So first, let's go ahead and add time. We're going to need a couple variables to make this work. We need to know the current time and we need to know the previous time, but most importantly, we need to know delta time, or the time that has passed between one update and the next. That delta time is how much we're going to be updating all of our elements. So for instance, if an object is based on velocity and it needs to move, that delta time is going to say how much it should have moved in that update time frame. So within our custom view, let's add these variables. Now time itself, when we query it from the system, is going to be a long. So we're going to want to store that inside of a long, but it's going to be private long current time. And we're going to just set that to 0. And then private long previous time is equal to 0. Now we're going to be storing the delta time as a floating point value. Specifically, the current and previous time are actually going to be storing millisecond values, and we don't want to be dealing with milliseconds. So we're going to convert that from milliseconds to seconds. And for that, I'm going to be working with a float value. But more importantly, it's going to be a public static float so that any object within the game can access this value and know how much time has transpired. So let's do public static float delta time. And just set that to 0 as well. So now we have our three variables, but now we need to set them up. The place that we're going to do this is actually within onDraw. The value is 0 here, and the current time is going to actually be a pretty big value. So we kind of need to seed things off right here within our custom view. So let's do current time is equal to system dot current time in milliseconds. And let's do previous time is just going to be equal to the current time. So everyone's at the same spot. Now where things differ is within onDraw. So between the time that onDraw occurred last time and this time, we need to know how much time has transpired. So first of all, we need to make sure that we get our current time. So let's do current time is equal to system dot current time in milliseconds. Now our delta time is going to be based upon how much time has transpired since this onDraw function was last fired by the Android system. So let's do delta time is going to be equal to our current time minus our previous time. Since current time should be larger than previous time, this all works out fine. We'll get a positive value for delta time. And at the end of our function, we're going to want to store our current time as our previous time so we can use it again next time. So let's do previous time is equal to current time. Great. So now we have a system for logging how much time has transpired between onDraw updates. So let's use that to our advantage and create a bouncing ball that will bounce on the screen back and forth. Let's create that new class. Right click, new, Java class. It's going to be called bouncing ball. And in our superclass, we're going to want to include our canvas object. Great, and hit OK. Here we are. It's going to yell at us because we need to implement those methods, so let's do that. Now we have our onDraw method, but more importantly, we need a constructor. So before we jump into the constructor though, let's think about what our bouncing ball actually needs to work properly. So the bouncing ball is going to need several properties. First of all, of course, is it's going to need a speed. And first, let's just do a protected float speed. And let's do a protected int color. Remember, color is stored as a hexadecimal value for ARGBs, so it's an integer value. And we use the color static methods to generate that color for us. So we want our bouncing ball to have speed and a color. Now, our bouncing ball is also going to need a position, right? Because if it's moving, we need to know where it was and where it will be in the future. So we need to log that information. So let's do a float x and a protected float y. So let's go ahead and do our radius. Because it's a bouncing ball, it's going to be a circle. So let's do protected float radius. And finally, if it's a bouncing ball, it has some form of a direction. But for this simple example, we're just going to mean that the ball can bounce from the left screen to the right screen and back and forth again. So let's just do a protected int direction. And we're going to set that to 1, meaning it's going to move in the positive direction. A negative value for direction means it'll move in the opposite direction. It'll make more sense in just a second. The last thing we need, of course, is a paint object. So let's do a protected paint object, and Alt-Enter to bring that in. All right, so Alt-Insert, let's make a constructor. So what values do we want to pass in? Well, speed, integer, float, yeah, that's all good. So let's say OK. Now I'm not particularly happy with the ordering of these elements. Typically I like the X coordinates first, so we're going to move them around a little bit. And we can do speed there, color, radius. Radius should really be closer to the front, I think. So let's move radius up here. There we are. That's something that seems more intuitive to me. And of course it uses the this modifier to make sure that all of the local parameters map over to the class-wide variables. Class instance variables. All right, so now we have more than enough information to make some stuff happen within OnDraw. So the first thing we really should do is draw the circle. And we're going to do that with the canvas object dot draw circle, Control P, and we have an X value, how convenient, a Y value, and a radius. It's almost like I knew what I was doing. And of course, a paint object. Now up here, we haven't done anything with paint, and we probably should prime that. So let's make sure we create a new paint object. Paint is equal to new paint, and paint.setColor. And the color is going to be whatever that color was that was passed in. So we'll do that right there. And now our paint object will work properly down here in our draw circle portion. Now, since this is a bouncing ball, we need to know the extents of how much we're supposed to go and then bounce back in the other direction. So we're going to need to do some logic. But first, how far did we move? That's the question. So we're going to just do this in the X direction at the moment. Once again, no vector classes, no directionality. We're just going to bounce from the left screen to the right screen and back and forth. So let's do X is equal to X plus our custom view.delta time. Now that's the amount of time that has transpired since the last update. And that's important because we need to know where we were and where we should be in the future. So time.delta time times our speed. That's going to be, speed is a position over time in terms of units. And when we multiply that by a delta time, that is basically turning into how much of an offset we had since the last update. And then, of course, direction. Direction is just a positive or negative value indicating that we should be moving to the left or to the right of the screen. Because of order of operations, all this will be evaluated first, and then the plus gets evaluated second, and that will be added back. You could also, of course, do plus equals if you wanted to, and get rid of that X. But it's up to you. Now we need to do some logic. We need to make sure we're not moving beyond the extents of the screen, which would be a problem because the ball would keep going and going and going, but not have anywhere to draw to directly. So let's do some tests. So if X is less than 0, well, if it's less than 0, we're off on the screen. So let's set X to be equal to 0 at that point, and we need to flip the direction. And the direction now should be positive, so I'll make that 1. Next up, though, is else if. And within that else if, we need to see if the X has actually gone past the element on the far side of the screen. To do that, if you remember from the last video, we created a getWidth function. So there we are. So we know now if we're past the edge of the screen. So let's set X equal to custom view.getScreenWidth. And our direction should now be in the negative direction, or moving back towards 0. If none of these conditions are met, we're just moving merrily along right here with our draw thing. Now, if you wanted to, you could take a few seconds and factor in the radius of the ball. Right now, the ball is going to go half off the screen before it bounces back. If we use the radius here, that means we can, of course, compensate for that so the ball looks like it hits the edge and immediately comes back for us. So let's actually do that. So if X is less than 0 plus the radius, remember the radius is half the distance on the circle, so that's the 0 plus that radius. And of course, if X is greater than the custom view.screenWidth plus our radius, it should bounce backwards now. Alright, so the next thing we need to do is actually create these balls on our screen. And for that, we're going to introduce something new. We're going to use the on-touch listener. So our custom view extends view, but it's going to implements on-touch listener. It's going to yell at us. We're going to want to implement that method. So let's go ahead and do that real quick. Alt insert and implement, and yes, on touch. There we are. We're going to return true because if we handle the event, we should be doing that. And within on touch, we get the view object that was dealt with, as well as the motion event that handled it. Before we get into the logic of putting our balls on the screen, let's make sure we initialize ourselves to handle touch events. So within our constructor, what we're going to want to do is this dot set on touch listener is this. That is, we're handling it ourselves. We're not using an external class to do that. Now, whenever there's a touch event, this functionality right here is going to be called and fired off. Now, normally, we're going to use a switch statement inside of here. Basically, we want to differentiate between different kinds of motion actions. So here, a motion event.getAction occurs, and within that, we're going to have some cases. The case is going to be a motion event.action, and you can see all the different actions we can handle. I'm going to do a, I guess, an action up. The idea is that the user has pushed their finger onto the screen, and now they are picking it up, and this is what's going to happen when they choose to take their finger off the screen. And what's going to happen is, of course, we're going to create a bouncing ball, and we're going to add that to our list right here, our array list of canvas objects. So let's do canvas objects dot add, and that's going to be a new, not mu, new bouncing ball. Control P for our parameter list. We're going to need the X and Y position, which we can get from the motion event dot get X and motion event dot get Y. Next up, we need our radius. We can set this to be whatever we want to. Let's say it's let's make it 40. Let's make it a really big radius. And next up is our speed. How fast is it going to move? Right now we're still working in pixels, which is not ideal because depending upon how many pixels a screen has, our gameplay is going to be different. But that's something we'll talk about in the future, dealing with the density of pixels on the screen. For right now, let's just do, I don't know, 100 pixels per second. And then our color. What is our color going to be? Well, let's use the color class dot RGB, and let's make it let's see, do 0 for the red, let's do 255 for the green, I don't know, 150 for the blue, so it's got a little bit of blue to it. Next up, Control P, we need a direction. We're going to start in the positive direction. So with that, we handle this event, and that should be it. So let's see what happens. Let's hit run and OK. So if you notice, the balls are rapidly moving back and forth. And this has to do with the fact that we're using milliseconds. So this is actually how fast they should be moving in milliseconds. That's not a good thing. So coming back over to delta time, that's current time minus the previous time. What I had forgotten to do is divide that by 1,000, because that's how many milliseconds are within a second. Let's go ahead and run that again and see the improvement. And here you can see now they're moving far more predictably. Let's see what happens when I hit the edge of that screen. Boop, boop. Uh-oh, they get locked. Boop. And you know why they get locked? It has to do with our bouncing ball code. So with an on draw, remember when I added that whole radius deal? Well, that radius is causing an issue with this value here, because really, x should be equal to x plus the radius. And down here, it should actually be the screen width minus the radius. Let's go ahead and hit run again and see if that fixes our problem. So let's create some circles over here. Boom, boom. And you can see they bounced off that side and changed direction. Boom, 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 boom. All of them again. Boom, 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 boom. And again. So hopefully you've seen this is a incredibly easy way for us to add animation to our canvas object and draw some interesting stuff. So I think in the next video, what we're going to do is, instead of diving deeper into this, we're going to jump into sound and how we can add some sound to our various game objects. Most importantly, I would imagine when they hit that side of the screen, they should be making like a bonk, bunk, bunk, bunk sound. Thank you for watching, and hope I see you next time. Have a good day, everyone. So long, bye.